Alrighty, folks. 13.4, the moment you've been waiting for, or maybe not, I don't know. We're going to be evaluating trig functions, inverse trig functions, that is, which we've already done. That's like when I say, hey, the sine of what equals 1/2, then we've been going to the unit circle and we've been looking for the place where sine, which is the y value, where does that equal 1/2? And then we look and we say, oh, here is the sine value of 1/2. So my first answer would be that theta could be 30 degrees, or I could call it pi over 6. Now, there's another spot, and the other spot was over here, and that's at 5 pi 6 or 150. So the second option is 150 or 5 pi over 6. So another way to write that question is to write it as sine inverse of 1/2. These two things mean the same. They're both asking you what angle has a y value of 1/2 in that case. So what we're going to be doing now is we're going to be evaluating those same trig functions, except we're going to be doing them on the calculator. Okay. So there are, believe it or not, other angles that are not 30, 45, and 60. So what if you're over here somewhere at like 20 degrees? Then what's the x, which is the cosine? Then what's the y, which is the sine? Then what's the tangent? So these values that we know only hold for those 30, 45s, and 60s, but we're looking at having to know significantly more of those because you got a 360-degree circle, and we've only talked about a handful of values. Now, the rest of them we use our calculator for. And so on this lesson and kind of leading into 13, 5, and 6, we're not going to be worried about the radian equivalents. We're going to be focusing on the degree options within the circle. The problem is that with functions, they have to pass the vertical line test, and then their inverses, if you remember, have to pass the horizontal line test. So there's all these kind of math specific things that limit where we can look for our answers on the calculator. So when you're doing sine inverse, you only can use quadrants 1 and 4, not 2, not 3. So basically, these two quadrants you can't pass through, and you can't give answers in that quadrant. So when you are doing a sine inverse question, or it might look like sine theta equals, and then you'll have a number, those are the same question, you'll either have an answer up here and have a positive theta, or if you're down here in quadrant 4, you're going to have to give your answer as a negative theta, because to call it positive 300, let's say, you would have had to travel through this band blacked out zone. So since you always start here for looking, you only can look up to pi halves or 90 and down to this negative 90. So for example, if I was doing sine inverse of negative 1/2, even on my unit circle, but I was using this restricted domain that we're learning about, I would have to look only on this side. There is no sign on the top part that's a negative 1/2. There is one right here, however, but I can't call it 330 because that would mean I'd have to go through the restricted zone. You can't do that. So the other way to get there is to just scoot down this way. And so if that's the case, my answer would have to be labeled as negative 30 degrees, not 330. So you really have to just kind of be really thoughtful in giving your answers, because you've got to just kind of think about, where am I going and can I call my answer that? So one of the places that you're going to have to be careful, one of the instances, is if you're doing a sine inverse of a negative number. That's going to always end up, because think of what that means. That means you have a negative y value. Negative y values only occur down here. This is the only quadrant you can start looking in, and the only way to get there is to go downward. So in those cases, you would have to name your theta using a negative value, like we did here, calling it negative 30, rather than going this way and calling it 330. Okay, cosine's easier, because when you're doing cosine inverse, I always say cosine is the cover and sine is the side. You can use the top two quadrants for your answers and not go down here. But the beauty of that is you don't have to go through these ever to get to one or two. So you can just call your answer whatever you get. You don't have to think about this kind of business because you can get everywhere you need to be. The problem here is you can go to one or you can go to four, but you can't pass through two and three to get to four. So this one's easy. You can pass through one to get to two, and that's your whole domain anyway. Tangent is the same exact restrictions as sine. So again, you're going to be the same boat with that. You can go to one, you can go to four, you cannot pass through two or three. So again, if you're doing the tangent inverse of a positive number, then you're going to end up with a positive theta because you'll just go up to find the value. If you're doing a tangent inverse of a negative number, you're going to be going down into quadrant 4. So that second scenario will be the same as with sine. If you have tan inverse of a negative value, you'll end up with a negative answer. Now your calculator is already programmed to do that, but the problem is it's only going to find you one of the answers that you need. So you're really going to have to kind of think through where you are, and then we're going to have to figure out how do we find the other one. So let's take a look. Sometimes you'll be asked to find an angle measure in a specific quadrant. So they're going to tell you like a range you have to be in. Sometimes it's helpful to draw a sketch so that you can see if you're in the quadrant they're asking for or not. Once you have found the initial answer, determine if your answer is in that quadrant. So if not, then you have to think about coterminal angles, reference angles, and so on. Because one option that you'll always have is if the answer you got is not in the correct quadrant, you could always add or subtract 360 degrees and see if that lands you in the correct quadrant. Now, when you are on the unit circle, there's always two places that have the same value. So we said earlier, sine was 1/2 here at 30 and here at 150. They add up to 180. The sine is, let's say, root 3 over 2 at 60 and also at 120. They add up to 180. That relationship always exists. So when you are going to use your calculator today to find your first option, and we'll call that theta 1, that's the one you got from your calculator. If theta 1 is your calculator answer, then to find with sine inverse, to find your second option, because you won't have the unit circle to just look at and look around for the second one, you will always take 180 minus your first option, because that's the relationship they have. They always total up to 180. Okay, what if I'm working with cosine? How will I find my second option if the calculator gives me one? Well, let's look. Here the cosine is root 3 over 2 at 30. The other place it's root 3 over 2 is down here at 330. So those two, instead of adding up to 180, add up to 360, and that's always the case. Let's say I go here where the cosine is negative root 3 over 2, 150. Then down here is the other place the cosine is negative root 3 over 2, 210. These also add up to 360. So the way we'll go about finding our second value if we're doing cosine inverse is to take 360 minus our first option that the calculator gave us. Because the calculator is always going to give us an answer in one of these zones. And then tangent inverse, to find our second option with tangent, the matching tangent is always straight across. So for example, here's a 1 at 45. I go straight across. That has a tangent value of 1 as well. So if you want to go straight across the circle, you have to add 180 degrees. So we'll be adding 180 to the first answer that we're given from our calculator. So there's a lot of really nitpicky things to think about as we kind of go through here. So let's do these examples and then we should be good to go. Alrighty, so the first example is looking for cosine. So I'll be entering cosine inverse of 0.4 into my calculator. For all of these, I want to make sure I'm in degree mode. So I'm going to go to mode and I'm going to check that I'm in degree mode rather than radian, because otherwise every single answer is going to come out wrong. All right, so then the other thing is it's telling me it wants me in the quadrant between 270 and 360. So it wants an answer over here. So I'm going to go to my calculator and I'm going to go to second cosine, so inverse cosine, 0.4. I'm asking my calculator what angle has that. And my first answer is going to be at 66.4 degrees. But the first answer that I get, which has to be in this zone because that's what the calculator does, is find an answer in that zone, cannot be the one I want because I'm trying to be down here into this quadrant. Okay, well, I have to be in between there. So I'm going to use my coterminal option because if the calculator one that I got isn't in the right zone, I either have to add or subtract 360. So in this case, because I have to stay below 360, I'm going to go ahead and subtract 360. And when I do that, I get my first angle as negative 293. Okay, well, is that going to be in this spot? Oh, I'm sorry. I did the wrong thing. I'm so dumb. Here's what I meant to do. I'm going to use my 360 minus that I talked about before. See, even teachers get confused with online learning. So if I do 360 and I subtract that 66.4 that I was given earlier, then I'm going to find 293 degree angle. And 293 degrees is exactly where I'm supposed to be, which is inside of that fourth quadrant. Okay, because the first one the calculator gave me isn't in the right spot, so these are all my options. Can I add or subtract 360 to be in the right spot? That didn't work. Adding would have made it too big, subtracting made it negative. So then I look, where are my second options? And when I used my cosine inverse second option process, I ended up with exactly what they said, an angle that has a cosine of 0.4 and it's in quadrant 4. This one is in quadrant, if you think between 90 and 180, this one's in quadrant 2. So let's look and see what I get. I kind of expect to get the answer I need from my calculator because cosine 1 and 2 is what my calculator is programmed to find. So I would do, again, second cosine because it's a cosine problem and it's asking me for the angle. And then I'm saying what angle has a cosine of negative 0.79. And it's giving me a first option of 142.2 degrees, which falls into that category. So then I don't have to do any more work. So I only have to use kind of all these tricks up here if the answer the calculator gives me isn't actually the one that I need in the end. So how about here? Between 180 and 270 is going to be in quadrant 3. So let's take a look and see. Now this one's a tangent. So if I do inverse tangent, and I'm looking for it to have a value of 4.7, then that tells me off my calculator that I'm getting 77.98, so about a 78 degree angle, but that's not in the right spot. 77 degrees is over here somewhere, and I want something over here. So I go and I look at my options with tangent inverse. The other place you get the same exact tangent is by taking 180 and adding it to that answer the calculator gave you. So if I add 180 to that answer I just got, now I have 257.98 degrees, which is going to be in between 180 and 270. So that was the one I was looking for. All right, here I'm going to be using a sine inverse, and 270 to 360 is looking for an answer in quadrant 4. But this one I'm going to be using sine, so I'm going to go second sine, and I'm looking for a sine value of negative 0.23. When I do that, I get an angle measure of negative 13.3, which is the right one, because remember up here, we talked about the fact that if you take the sine inverse of a negative, you're going to get a negative because your calculator knows it can't go that direction. But according to this, we're supposed to be between 270 and 360. But I'm not looking for a different place. I'm in the right place. Here I was going the wrong direction, so I needed the second option. Here I was going the wrong direction, so I needed a second option. But right here, this is the right direction. I just need to be calling it something that lands in this range. So I'll try my other option and just go with its coterminal, which doesn't change where I'm landing. It just changes the value of that. So I would add 360 and say, how about if I call this is still my first option from the calculator, but I just added a trip around the circle. Now it's 346.7 degrees, which is pointing the right direction and is in the right quadrant. Tricky, huh? Got to actually use your brain. Back to sine inverse. I'm trying to be between 90 and 180, so I'm trying to stay in quadrant 2. So if I do inverse sine of 0.46, it's telling me that my angle is a 27. So the first angle I got is 27.4 degrees or so, but that is absolutely not the right direction. So adding 360 won't help because I don't need something that ends in the same spot. I need to go for my other option. And with sine, my other option is found by taking 180 minus the value I just got from my calculator. So 180 minus that answer puts me at a second option of 152.6 degrees. So here, the first option I got was going the totally wrong direction. So I know I needed to use one of these. In my last one, the arrow was going the right way. It was just called the wrong thing to fit into this range. So then I just used my coterminal. So you have to kind of sketch it out and see if you're landing in the right spot, but not in the right number zone. Then you'll just be adding or subtracting 360. If when you draw your angle, it's just in the completely wrong direction, then you'll be using these second options. Hopefully that's getting a little more clear. So here, between 180 and 270 puts me in quadrant 3. So I go to my calculator and I'm going to do second sine, and I'm looking for an inverse sine of negative 0.23. So that's telling me that my first place is at negative 13.3 degrees. If I sketch a negative 13 degree angle, that is not in the right spot. So adding 360 won't help me. I have to go for my alternative second option. Looking at sine inverse, I need to do 180 minus what I got, even though that's a negative. So they'll end up adding because I'm going to be taking 180 minus negative 13. So then my second option is 193.3 degrees, which falls in the category that I'm looking for. So it's gotten me into that proper range. Okay, I am going to quit there. I know that if you're using the online sheet, you have some notes on this part as well. I'm not going to go through that right now, and I'm going to look ahead and see if you even really need to know that. It's basically reviewing because we have already done this. Here you would look these up on the unit circle. And here you would just type directly into your calculator, and then you would have to do radians and degrees, but this year we aren't focusing on the radians. So I'm going to skip these notes for now, and I'm going to leave it go with just this. And then when you go to do your 13.4 worksheet, which is posted online, this front is going to be what we've done, but you don't have to do the radians in this first part because it says radians and degrees. I just want you to give your answer in degrees. This is exactly like what we've done in the notes. And then the back is just review, which is good for you to kind of take a look at. This is way too zoomed in for you to go through and practice so that you feel like you have an overall understanding of what we're doing because this is all still part of chapter 13. So hopefully that helps. Otherwise, join me in some of the optional sessions this week. We are only tackling 13.4. You're going to have a worksheet, a Go formative, and also a quizzes on this. So if you have you need extra help, tune into one of those sessions or shoot me an email. Have a great day, guys. Bye.